Right, so the Pythagorean Theorem. So as we saw in the video, the math antics video, the Pythagorean Theorem has to do with right triangles. And it's a theorem, meaning it's something that can be proven. And it is the most proven mathematical theorem of all time. Nothing has more unique proofs than the Pythagorean Theorem. There's over 2,000 unique theorems for this. And even the U.S. president came up with his own theorem. James Garfield, president back in the 1800s, came up with his own unique proof for the Pythagorean theorem. So let's start off. We'll make a right triangle. Let's draw a right triangle. That's kind of a funky looking right triangle, but oh well.
Does the line have to be straight, or does it have to be?
Yeah, you have to make a right angle. Yeah, that line should be straight. I kind of warped it. I apologize for that. Okay. So remember they labeled the sides, but let's talk about the sides. These two sides that form the right angle. In the video, they gave it a name the same as a body part. Do you remember what they're called? Starts with an L. They're the legs. They're the legs. So the legs of the right triangle are the two sides that form the right angle. The side that's opposite, the side that I gave it a little warp there. Yes.
Since the equation is sides together, are we always going to get two sides?
Yeah, you're always going to know two of the three sides. When you get into trigonometry and in your geometry class, you may only know an angle and the one side, but that's later. Okay, so the side that's opposite the right angle, it has another unique name. It's ancient Greek, though. Started with an H. It's called the hypotenuse. Hypotenuse. Hypotenuse, which in Aramaic, I believe that's the language it was from, literally means longest side. That's what it means, longest side. All right. So we usually label them with letters, the lengths. So the legs always take up the letters A and B, and it doesn't matter which one is which. So I can call this one A and this one B, or vice versa. But the longest side always has to be the hypotenuse, but it always has to be the letter C. We reserve C for the hypotenuse. Okay, so it's important to identify which one that is. And so here is the Pythagorean theorem. In a right triangle, with legs A and B and hypotenuse C, all we're doing here is basically labeling the sides A, B, and C, comma, A squared plus B squared equals C squared. Okay. So we need a couple of things here. We need to make sure it's a right triangle. This only works for right triangles, but that's one of the probably the most important of all the types of triangles. A squared plus B squared equals C squared. Okay.
Will you ever do a problem like where we have to do 3 instead of 2 to the power of 2 instead of 2?
Oh, not here. No. In fact, well, that's dealing into some other stuff. It works for powers of 1. It works for powers of 2. It works for powers of 3, and that's it. Nothing over powers of 3. Hmm?
So this theorem only works to the third power.
Yeah, and that's looking at 3-dimensional stuff. And that's another theorem. There's a theorem that says, okay, you can't do a to the n plus b to the n equals c to the n for anything for n greater than or equal to 4. That's called Fairmont's last theorem. He said, I proved it, but I didn't have enough room on my paper to show you. But trust me, it's true that you can't do this type of relationship for anything greater than 3. Well, it took like 400 years later to actually prove it. Some guy about 20 years ago proved it. So yeah, some of these proofs can take hundreds of years to actually prove. So yeah, we won't be dealing with anything other than this. Okay.
Does that make it easier or hard?
Easy. So let's see. What we're going to do is we're going to find the missing side of the right triangle. So we're learning about this now. You'll revisit it again in geometry, and then there you really run crazy with it and learn about trigonometry, which is part of this. All right. So let's start with the right triangle, okay? Number 1. Let me give you a right triangle. Let's all draw a right triangle. Maybe I'll do a better job this time. Here's my right triangle. Let's say this is 9. It could be 9 inches, 9 feet, 9 miles. Let's say this is 12. So we know 2 of the legs. Okay? Let's label them. So the first thing we always have to do when we label is find your hypotenuse. Hop over that right triangle, right angle. Find the right angle, look across. This is C, and C is the part we don't know. So now we have to label the other sides A and B, because C always has to be the hypotenuse. So what should we call 9? A or B? Doesn't matter. So let's call it A. That makes this B. Okay? So now we take our Pythagorean theorem, which says in this right triangle, A squared plus B squared equals C squared. And we replace A and B with actual numbers. So that would be 9 squared here, 12 squared here, equals, we don't know C, so leave it as C squared. And now let's square some numbers. So remember, we're squaring. This doesn't mean 9 times 2. It means 9 twice. So it's 9 times 9. 81. Same thing here. That's not 24. It's 12 times 12. Okay. And now we want to add that. So that would be 225.
No. Oh, wait.
Yeah.
Oh, yeah.
So now we just figured out that C squared is 225. But we don't want C squared. We want C. Yes, we want to undo the squaring. We want the opposite. Just like we would do the same the opposite operation on both sides. When we had addition, we do subtraction. When we had multiplication, we do the division. Here we square root. So what we're asking is what number times itself equals, Well, first of all, this cancels. The squaring cancels, and it's just going to be c. But we're asking what number times itself is 225. And if you're not sure, well, that's where a calculator could come in handy, your phone, the Chromebook. If you ever need to find a square root on a Chromebook, let me show you. You want to type in SQRT. So little side note for the, so just by typing SQRT 225, you will get the square root. Let's take a look. Okay, so we just found that the square root of 225 is c. So basically, c equals 15. So this missing side is 15. Okay. Any questions? Okay, let's just do one more here. Number 2. Okay, let's get a right triangle going. Okay, so here's my right triangle. Let's say this is 5.1. This is 2.3. And again, they could be inches, centimeters, millimeters, miles, kilometers, whatever. Let's find C. There it is. Our missing side is C. So what shall we call our other sides? A and B. A is here. Let's say B is this one this time. I just randomly chose A to be the one that's vertical. Okay. Well, let's plug it all in. A squared plus B squared equals C squared. We'll replace A with 5.1, B with 2.3, and here's where a calculator might come in handy. So let's see. We want to square 5.1. If your calculator has the square feature, like you see this button that squares, that's easy. There it is, 26.01. Yes. Here, close it right now. We'll get there. All right. Now, if your calculator doesn't, you just multiply the number times itself. So in this case, 2.3 times 2.3. And you get 5.29. All right. And then we'll just add those two numbers. And that's 31.3. And once we get to this point, it's c squared equals something. We'll undo the square rooting or the squaring with the square root. Cancel that. And on the calculator, there usually is some sort of a square root feature. So on my calculator here, I press second and then x squared. And there's a square root feature, and I just put in 31.3. And the square root of 31.3 is 5.59, blah, blah, blah. And like Santiago mentioned, we do have to round this to the nearest tenth, one decimal place. So is this 5.5 or 5.6? 5.6. So 5.6 is our answer. All right. And so this is what we're going to be doing on today's assignment. It's on IXL. We'll be using the Pythagorean Theorem to find the hypotenuse of right triangles. Okay.